Hey there, AQR students. Before we get to the packet, the SAS7 packet, we're going to do a very quick review here because we're going to be talking about these things in the packet. Relationships and math. So we have direct relationships and inverse relationships, also called variations. Direct variation, inverse variation. If we have a direct variation, what that means is, we're talking about two things, two variables. When one variable increases, the second variable increases. Likewise, if one variable decreases, the other one has to decrease. Okay? An example of this would be shoe size and height. Generally speaking, the bigger someone's shoe size is, the taller they are. The smaller the shoe size is, the shorter they are. It's not a hard and fast rule, but in general, that's going to be a true statement. Okay? And that's going to look like, mathematically, it'll look like the equation y equals kx, where x and y are your two variables, and k is some kind of what we call a constant of proportionality. Okay? Your direct variation constant. K is going to be a constant. It's going to be some number. Depending on the situation, it'll be some number that we can use then to guess stuff. All right? Second type of relationship is an inverse relationship. Inverse means when one variable increases, the second variable decreases. They do opposite things. And so an example of this would be altitude and atmospheric pressure. The higher you are off the earth, the smaller the atmospheric pressure is, which means when you're up in high altitudes, it makes it very difficult to breathe because of that. Okay? As altitude increases, the atmospheric pressure decreases. All right? And the way that goes mathematically is y is equal to k over x. So if x starts getting really big, that means y is going to get very much smaller because we'll have some number divided by a big denominator. It means that gets closer and closer to 0. Okay? All right. So having said that, we're now looking at SAS7. Investment probability. So interest rates are a measure among many other factors of risk. The more risky an investment is in actuality and perception, the higher the rate of return. So in general, if it's a risky thing, you're more likely to lose money, but you're also more likely to make more money. In general, stocks, an investment security that gives you ownership in a company, are riskier than bonds, a security in which you actually lend money to a company. Thus, the rate of return is much higher for stocks than bonds on average. Stocks have a rate of return of 10% annually and bonds 5% annually. So use the following information when working through these activities. First bullet, all investments have a rate of return which sometimes can be negative. If you have a negative rate of return, it means you are losing money on that investment. Second bullet, the rate of return on stocks is a percentage called a return on investment, ROI, that compounds not from interest payments, but from an overall annual increase based on a price per share that changes daily. So as the stock price goes up, that's where your wealth is. All right, the stock price will go up. So you bought it for $10. If it goes up to $20, you've doubled your money because now you can sell it for twice as much. Third bullet, the rate of return on bonds is an actual interest rate percentage that is assumed to compound much like a certificate of deposit, but may not if you decide not to reinvest the interest. The fourth bullet, financial analysts use the time value of money, TVM, based on risk, rate of return, and the relationship it has with other investments to determine the market value or price of a share of stock or bond. And finally, the last bullet here, although interest rates are used in bonds, financial experts use interest as the lending rate that the Federal Reserve sets for banks. This may not seem related to stock prices or bonds, but the interest rate set by the Fed Reserve affects the value of all investments. If the interest rate changes, that's a big deal news item. Okay, it doesn't happen all that often, maybe a few times a year. That's it. All right, maybe not even that much. So let's look at our number one here. Stock Texas is worth $14.92 per share on Monday. The interest rate drops on Tuesday, and Stock Texas is worth $15.04 per share. So what type of relationship can you assume that Stock Texas has with interest rates? All right, and this goes back to what I started with in that little pre-lesson. Is this a direct or an inverse relationship? All right, tell me why. And then finally, what does this relationship imply about the risk of stocks compared to bonds? Explain your reasoning here. Well, I'm not that interested in that. But really, what kind of relationship is this? Is this direct or is it inverse? Okay, number 2. On Wednesday, Bond Austin has the best risk rating. So AAA, AAA, that's a AAA rating. That's your highest rating you can have. And it has a price of $72 with a AAA rating. On Thursday, the risk rating drops to a lower rating of AA, a AA, and the price drops to $64. So what type of relationship can you assume that the price of Bond Austin has with its risk ratings? Again, is this direct or is it inverse? And why? Okay. Do you think that this is a reasonable assumption about the relationship between bonds and risk ratings? Why or why not? So pause the tape if you need to and work that out. All right, so let's look at number 3. Assume losing a letter is considered 1 unit of risk and you assign the highest, meaning better rating, a 9. What does the price of Bond Austin drop to if the risk rating suddenly becomes a BB, a double B, which is a risk rating of 5? So what we have a $72 price with the AAA. That's your highest, that's a 9. All right. So what we're going to do is we're going to take our price and we're going to take our rating. That's our ratio. So when the price is $72, we have a rating of a 9. That's the highest. It's a AAA, $72. And now it's dropped to a rating of a 5, and the question is, what's the price now? So it's a proportional relationship. We'll let you solve that, and we'll put that on the form for you to answer. So stop the tape, work that out. All right, let's look at number 4. Stock Texas has a price of $156 per share when Bond Austin has a price of $23 per bond. Use an equation modeling the inverse variation between stock and bond prices to predict the price of Stock Texas when Bond Austin is worth $75. All right, so we're going to use the inverse variation, y equals k over x. Y is going to be, let's let that be the price of Stock Texas. We'll let X be the price of Bond Austin. And K is, like I said, K is our constant of proportionality here. So plug those numbers in. We're going to plug in 156 and 23. We'll say 156 equals K over 23. Figure out what K is. All right? K equals what? Work that out. All right, once you have that, we want to use that K value to predict the price of Stock Texas. So we're going to say Y, price of Stock Texas, equals K, whatever the K is here, we're going to put it in up here, and then we're going to divide it by 75, and that should give us the price of Stock Texas. Okay? Second part of this, what if the stock price, Y, so again, Y equals K over X, now we're going to put 7176 in for Y. We're still going to use that same K value from up here. It's going to go in right here. And then you want to solve that for X. So you're going to have to do a little algebra here to solve that for X. Figure out what X is going to divide into K so that your answer is 7176. So see if you can work that out. Okay, for number 5 then, we've worked out what X is here. How certain is this prediction? All right, any of these predictions. How certain is this prediction? What other factors, is that a sure thing? You know, if this is a true thing up here, is it also going to be true down here? What other factors could affect the price of either investment besides this? Pause the tape, answer that. All right, for the last problem here, number 6. Emily, who is 25 years old, has $25,000 to invest. She wants to invest in stocks, bonds, and or cash accounts, collectively called an investment portfolio. Currently, interest rates and inflation are relatively low, but seem to be on the rise. Decide the percentage and amount that Emily should invest in each category. So she's going to split up this $25,000 between these three things: stocks, bonds, and cash, a cash account. And so just to get us all on the same page here, I'm going to say, let's just say we're going to put 40% into stocks, 40% into bonds, 20% into cash. Okay, so that we're going to take 0.4, multiply that times 25,000, that's 40%. Going to get the same thing here for bonds. So this will be the amount she puts into stocks. This will be the amount she puts into bonds. And then 0.2 times 25,000, that'll be the amount she puts into cash. That should add up to $25,000 after we get all that. All right. And then what I want you to do with that, all right, what I want you to do, once you have these numbers, you're going to come down here to the third section, and you're going to use the TVM calculator. Use your TVM calculator. Emily will keep her investment for 35 years, so that's your time. And you can use Grunderware on this one. You don't have to deal with payments, so if you want to use Grunderware, that's fine. If you want to use the other one, that works fine too. Either one should work for this particular thing. So 35 years is your time for retirement. Using the portfolio you develop, these three things, to find the future value of each category. If stocks are gaining 12% each year, and this is going to be compound interest, bonds 6% per year, cash 3% per year. So take these values, present value for each one, and figure out how much you're going to have at the end of 35 years. Okay? Then finally, last step, take those answers. All right, we're going to take our answers, our three answers. We're going to have an answer for stock here. You're going to have an answer for bonds, and you're going to have an answer for cash. All right, let me just call them A, B, and C here. And your last step is going to be, what is the expected value if the probability of realizing the average rate for stocks is 65, 0.65, bonds is 0.8, and cash is 0.95. So you're going to take A and multiply it times 0.65. You're going to take B, you're going to multiply it times 0.8. And you're going to take C, cash, you're going to multiply that times 0.95. So that's a pretty sure thing that cash is going to get the 3%. Fairly certain that the bonds will get 6%. And then not quite as certain, about 2 out of 3 chance that you'll get 12% on the stocks. Okay? And so then you'll have three values here. I don't know if I ask for those separately or if I ask you to add them together when we get to the form for you to do on Schoology. All right, that's the whole thing. So there's only one video for this one. I hope you understand it okay. Send me an email if you have any questions about anything, and I will talk to you later. Bye-bye.